Right, so unfortunately, I made the mistake of not, well, filming the previous episode and then unfortunately ending it when I was clicked to end the transcript. I accidentally ended the whole live stream. So unfortunately, the whole video is gone. But as a sort of kind of compensation, I'm just going to be going through the same material again. Unfortunately, there won't be the same engagement that I was received. There were some really, really good comments made, questions asked, and just kind of conversation between us, between me and the great people joining the session. But unfortunately, that's not going to be able to be replicated. However, I will still be able to teach the content. So today's lesson is going to be on NFTs. Now, the contents of this lesson, well, yeah, introduction to what an NFT is, what their utility is, what can they be used for. I personally view them as far more than just digital art. Where you can look for help, and then actually beginning the coding. So creating, minting, and then finally transferring an NFT. And then we're going to be getting a sneak peek into next week's session, which will be on fungible tokens. So what is an NFT? Well, an NFT is a non-fungible token. And there's kind of three aspects which I believe are highly valuable regarding NFTs. And that's one, that they're unique. So as the description says, no two NFTs are the same. This means that it's totally possible to verify whether something is a fake NFT or not, because every single NFT is unique. Therefore, if you do not have this particular exact NFT, and that is the criteria of what you're desiring, then you know it's a fake. Equally, they're indivisible. So, for example, you cannot have half of an NFT. Nobody can own 2/3 of an NFT or 2.3 or whatever. But you can, for example, own 1.3 Bitcoin or 1.3 of a fungible token. Now, what this means is it's good for tokenized assets in particular, things which typically just have one owner. Of course, there are kind of ways where you can share ownership of an NFT using maybe smart contracts or something. But inherently, yeah, you can only have one NFT, or two, or three, or four, etc. An integer. Finally, they have metadata. Now, metadata is used for a wide range of purposes. Essentially, what metadata is it's immutable data built into this NFT, and this is what actually gives the NFT far more use case, a far wider range of use cases than simply just digital art. And you'll actually find that the digital art, which perhaps represents the NFT, is also found within the metadata. But besides that, you can have other things. For example, let's say you're doing an NFT certificate, then you can have the aspects within that qualification or something like that. The range is really massive. So I mentioned tokenized assets, and NFTs can be used to represent off-chain data and bring them on-chain. Now, something like this would, for example, be property, or event tickets or certificates. I briefly mentioned certificates earlier. But things like property, if you're able to put this data on-chain and assign the ownership to an account, when it comes to transferring that property, you'll be able to do it very, very easily without having to use intermediaries such as lawyers or other parties, which there are multiple parties involved in the transaction of a house. Simply, you can say, okay, I own this property because I own the token which represents this property. Resources that you can check out. So yeah, obviously the documentation, they've got really, really good stuff on creating and transferring NFTs. This is going to be very similar to what I do today. But yeah, just kind of a nice run through. You can also have a look in this SDK section, and in token service, there's a bit more information on NFTs and creating a token. But yeah, if you also want to look at tokenized assets, you can follow this link here. Also good for understanding a bit more about them. So yeah, let's code. I'm just going to head over to the code now, which I created in the... how do I scope this? So yeah, I'm just going to head over to the code now, which I created in the lesson. So here I've got the code. Obviously, it's already been written, and I'll also link the repository, which is more. It's a different file to this, more structured. And essentially, the first file which we created was this create NFT file. Now I'm not going to code it, obviously it's already been done. I'm just going to run through kind of each aspect to it. So we imported, firstly we configured our private key and accounts as we usually do. Obviously this client is going to be the fee payer. Now you may notice there's something slightly different over here, and I'm just going to zoom in. And that's that rather than just importing this private key as process.env.private key, we've actually wrapped it with this private key.from string function. Now what this does is it converts the private key from being just a string. As you can see, this account ID is of the type string. Over here, the private key is of the type private key. Now this is useful because further down the line, we need to use the public key, which we can get from the private key. But so over here, for example, we go private key dot public key. So we're actually accessing a property of this private key object, which wouldn't be possible if we had only just set it as process.env.private key. So you'll actually see if I delete this and save it, now it goes to private key string undefined. And for example, if I try access this variable .pub, it doesn't pop up. However, let's go back a bit. Now that we've made it back in this private key form, if I go to try access that property now, .public key, as you can see, it appears over here. And that's because we've converted it into the correct object. Now this is a bit further down the line, but essentially we've configured the client to be like this. Doesn't make a difference when it comes to passing it into this setting operator method. And then we've imported the particular functions and classes we need from the Hashgraph SDK. So we imported the client one, we've used that already. We imported the private key, that's so we can actually use this particular method. And we're also importing the token transaction class, and we're importing the token type class. Now, over in our create NFT function, we're just going to follow the very, very similar flow to which we've been following already. So we're going to create our transaction. It's going to be a new token transaction, and now we're setting the properties within this particular object, which we're then going to send off. So we've got the token create transaction. We've set a token name. We've set a token symbol. These can be anything you want. We've set a token type. This is where we specify that it's an NFT. So this is why we've imported token type over here, because we're going to say, okay, we're giving a token type of non-fungible unique. That means NFT. If you choose to exclude this, then what will happen is Hedera Hashgraph will automatically assume that you want to do a fungible token. So if you're doing a fungible token, it's not necessary to set it. If you're doing an NFT, you must set it. Then we're going to set the supply key. What the supply key is doing is it's giving us a key, it's giving us an account which will be used to mint or burn particular NFTs. So if we didn't set this, we wouldn't have the ability to mint new NFTs. Finally, we're setting the treasury account ID. The treasury account ID is the account which receives the NFT upon mint. And usually you have to sign with the account ID, who is the treasury key. However, because our treasury account is just our client, we don't actually need to sign it again. But if we were to use a different account ID, we'd have to freeze the transaction. So we'd say freeze with client, and then we'd have to sign it, and have to sign it afterwards with the key. Now, of course, like I said, because we're using the same account payer as the treasury account, we don't need to sign it twice. This counts as a signing. Then we're getting the receipt, and we're minting the token ID. To run this, all we'd have to do is we just have to save it, and then we go node, and then we'd say create NFT, click enter. As you can see, we've now created a token of this type, of this token ID. So what we then do is we then go over to our new file which we built, which was the mint NFT file. Now, what the mint NFT file, this is the file which actually, okay, we've created our NFT ID, we've created the class. Now we're going to print and mint out an individual NFT of this class. So again, to do that, we're going to configure our, just copy basically the stuff we had from before, configure our client, and we're going to perform a token mint transaction. So we need to import the token mint transaction. Inside this mint NFT, we're then going to be following the same flow as usual. Create a transaction, so build the transaction. This is going to be a token mint transaction. We're going to set the account ID with the token which we've just created, and then we're going to be setting the metadata. Now, this is something which is a bit probably looks a bit weird. Like, why are we setting this metadata? What we're doing over here is this is a link to what's called a CID, content identifier, from IPFS. IPFS is a decentralized storage platform which a lot of the Web3 space is building upon. I really, really like IPFS. They're also powered by the same team who do Filecoin, which is Protocol Labs. Really, really cool guys. But essentially what this CID does, it links to metadata stored on the decentralized web. So I'm actually going to show you what this metadata looks like. So to do that, I need to get my IPFS daemon running. Now it's running. I can then head over to this decentralized web, my node. And what I can do is I can search for this CID. This is a CID which I uploaded myself. As you can see, it prints back an object which has the name, the creator, the description, and it's also got an image. This is the NFT metadata which I was referring to earlier. And this NFT metadata can really be whatever you want. So for example, let's say we're doing it for a certificate. We could say, okay, the name is from Jake, the result was an A, and he did well in blah, 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 something like that. Now, this image is a link to another CID, which again, if we search this in here and we open it on the public gateway, this is the image which again I've uploaded to this decentralized web, all totally for free. Like, this stuff is absolutely awesome. I don't work for IPFS or anything. I just use their technology and I love it. Right, so you might notice that I'm in a slightly different top and maybe my screen's slightly different. That's because when I was previously recording this lesson, the testnet was actually down. So I was calling these functions and it wasn't working like it usually should. But obviously, so what I'm going to do is I'm just going to create a new NFT. We'll then use the newly generated NFT token ID. And we're just going to use that to mint the NFT and then send the NFT. I've already explained, obviously, what this mint NFT function is doing. So let's mint a new one. I'm going to say node create NFT. That will pop our token ID here. One other thing that might be slightly different is I've added the receipt in just because I was trying to debug it. Anyway, copy and paste this. And we then paste it in here. And then what I'll do is I shall save and run this node mint NFT file. And if it's successful, minted NFT with serial 1. So it's saying serial 1 because this is the first NFT of this class. This serial is what makes NFTs of the same token ID unique. And actually, if I then mint this function again, I'm going to get 2. So that can go until forever, pretty much. Finally then, like I said, because I've already talked about this, I'm going to move over to the send NFT function. And this is very, very similar to the transfer transaction, which we built in the first lesson. And so we're basically going to be adding a new transfer transaction, except instead of adding an HBAR transfer, we're going to be adding an NFT transfer. So as you can see over here, it tells us what the arguments of the function are. So we can pass in the token ID or NFT ID. We can pass in the sender account or serial number. This depends on whether you've passed in the NFT ID over here. But the way that we've done it is we've passed in, okay, this is the token ID. As you can see, it matches, it doesn't match it because I haven't updated it. So this should match. And then it's got the serial number. So at the moment, we've got a serial 1 and 2. Those are the only serials that exist. If I try to send serial 3, will cause an error because serial 3 hasn't been minted yet. And then we've got the account ID. So this is the person who is going to be sending the NFT, or the treasury account. And finally, we've got the account which I want to send it to. And that is just one of my Hashpack wallets. So we can check. I'm just putting the password in. So yeah, this is going to be the account which receives it. I think at the moment it doesn't have any of these NFTs. So we can actually send this NFT, node send NFT. Just one thing to note. So obviously, because our treasury account, this sender account, is the same as our fee paying account, the person who executes it, we don't need to sign it because we've already signed it in this execute function. However, if we're going to be sending it from a different treasury account and a different fee paying account, we'd need to add a sign, and then first we'd need to freeze the transaction. So we'd say freeze with, and we'd say freeze with client. And then after that, we'd then sign it with whatever the treasury key is. Obviously at the moment, treasury key doesn't even exist because we haven't defined it as a variable. But because we are executing it with the client, we don't actually need to sign it with the treasury key because we're already signing it essentially. So I'm going to hit enter on that, and let's have a look. It's caused an error. Cool, good. I like errors. So it's caused an error because token is not associated to the account. Of course. So with Hashpack, and it's a good thing I made this error. With Hashpack, with Hedera Hashgraph in general, not exclusively to Hashpack, then you need to associate yourself to a token before you're able to receive it. Now, the reason why that is so that you don't get kind of spam tokens into your account. And obviously, in things like Ethereum, it's quite unrealistic to get a spam token because they're so expensive. But with Hedera Hashgraph, because it's so cheap, it's really not that unfeasible that you'll receive some spam tokens. So we're actually going to firstly go into assets and click add token, and we're then going to associate our token. So that's the token we want to send. And what associating the token will do is it's going to say, okay, yeah, I will accept involvement, and I would accept kind of the ability for me to receive this token and then transact with it. So let's clear the console. Let's click up on the keypad twice because it tells you what the previously entered thing is. So last it was clear, before that was nodes NFT, and status code is 2022, not 2022. So that is all good. If we then go into our Hashpack wallet, let's refresh it. And there we go. We've got our NFT by J. Cool. This is an NFT created in Sassoon Hashgraphs in the blah blah blah. And this is coming from the NFT metadata actually. Likewise, it says by J. Cool there. That's from the NFT metadata and serial number 1. And yeah, that's basically a brief summary of kind of what we covered in the previous lesson. Like I said, I can't unfortunately match the quality of the conversation. However, unfortunately, this is gonna have to be kind of have to make do. Next episode is going to be on fungible tokens or cryptocurrencies. So yeah, that's going to be live at Sunday the 13th, 7 p.m. Sunday the 13th of November. If you're watching this in the future, then unfortunately you've missed it, but hopefully I'm doing a new course. So yeah, all the best guys, and bye.